Okay, so let's move forward with the muscles. It's basically the same thing, but much more basic. So we're gonna do another stream here. We're gonna actually just gonna take these and call it blobs here as well. So we have that. We're gonna call it blobs, and we're gonna give it a fresh color. Let's give it a random color. Yeah, I haven't used that. And down here we can just take this. We can call it grouping. We can give this another color. That's very much the same color, so we give it that. And then we're going to do muscles. So that's not that hard. We're going to start with a sphere. We can give it no uniform scale 0.8, polygon, and give it 100 maybe. I don't know if it's needed, but we do it anyway. We could also have just gonna see here, we can have this as template just to see. So it's quite a lot of skin in this setup, but that's fine. We're gonna give this normals. I don't know if it's necessary, but still we do it. Put on a merge because this is like the base for the body. And we're gonna bring in a line. Similar as we did last time. Gonna make it 1.35, and we're gonna give it a lot of points, 250. And we're gonna do wrangle here. The reason for that is because I want to, maybe it's not really necessary now, but I did a setup where you had a bit of, because the arms kind of shape the other arms, so I needed a little bit more there, but I don't know if it's that necessary. So we're gonna give it a u attribute, same as last time. So we're just gonna do f at u equals to float at ptnum divided by float at numpt minus 1. So there we go. And then we're gonna set the p-scale. And what we could do is we could probably copy the other p-scale. So I'm gonna copy that. You could copy a lot of the setups, but I'm just gonna do it like this. So yeah. So set p-scale here. We gonna take this down to 0.15. And we're also gonna reshape it a little bit because we want it to go. Because the thing is, like, the arms could easily be move outside the skin and become end up on the inside of the body, which we don't like. So in order to fix that, we do something like this. We shape it a bit like this, and therefore it's hard for this part to go inside this part. Yeah, hope it makes sense. Then we can do a sweep, and what we pretty much can do is that we could pretty much keep this circle thing here. So we could put another null here and call this out circle shape. And we can just object merge it in. We get this, which is good. We're gonna do the same thing as we did the other time. We're gonna fuse, and we're gonna reverse. We're gonna give it normals. So that's good. And then we do the transformation again. So yeah, can just probably copy things. It's not exactly the same, but pretty much. So we're gonna do minus 0.7, and we're gonna rotate it, sorry, not transform, rotate 90 degrees for the first part. And we're gonna do another transform down here. And I'm gonna do the same thing here, -3 in rotation. And that's pretty much it. Then we're gonna copy it. And what we're gonna do is we're gonna do 10 copies. And we're gonna do 34.75. And then we'll do a merge. And we're gonna take these two, copy them again. And for the second one, we're gonna translate this 0.5, 0.4, 27, and 0.85. See, we had no, yeah, I think that's correct. And then we're gonna copy, and the copy should be 12, and it should be 30 degrees. I'm gonna merge it. And then the last one, we're gonna do minus 0.25, 0.25, 27, you might remember this, 0.5. And then for the copy, we do a few more, we do 15, and we do 69.5, and we merge it in as well. And there we go with these. And if we compare to the other arms, which are here, no, that's sucker. Here are the arms, sorry. No, there are the arms. You can see that we are inside our other arms, which is exactly what we want. And we're not outside anywhere. And I mean, here you can do pretty much what you want. You could do make them longer. There's like a very good reason for making them longer. I made them like this, but in hindsight I should probably make them longer so we can see what it looks like if we do 0.45 instead. I think that might be better. We can even try to stretch it to 55. I think that could be good. The small ones, I think it's inside everywhere, which is the important thing here. Yeah, they are. So I think that's fine. Yeah, now it's just a matter of we're gonna do connectivity here, because we will want that later on. So we're gonna do connectivity on the point, and we're gonna call it arms class. This will be able to give us random stuff for each arm later on if we want to. Then we're gonna do a VDB from polygon. We could actually make this a different stream and use it down there. Doesn't really matter if we do it yet because we'll use it anyway. But it could be good to keep. And we don't have to be as small here, but we could, oh sorry, one zero too much. We could do something like this probably. Yeah, that's good. And I think we could maybe, no we shouldn't. It's very much as big as it could be. It shouldn't be too big because we want some skin all over the place, but it's cool to have different amount of skin. Gives it a little bit of depth, so it's cool that we have this that will be different than other things. Anyway, we might have to dilate it a little bit, so we're gonna do that because we want to smooth it. So if we dilate it, maybe like 1, and then we do a VDB. Now it's a little bit outside, but when we do a VDB smooth and do a lot of iterations, which we want, we get something like this, so it shrinks down. And if you compare the two, we're pretty much at the same place. Maybe we should dilate it to 0.5 instead. So if we compare this with this, we're pretty much in the same place. We lose a little in the end, but that's fine. Oh, it's not fine because those are outside. And I think that's a bit strange. I think like I don't know why I had this movement that didn't really fit here. Because what happens if we remove that? I think it's better in the center there, right? Yeah. I don't know why I had that movement because I don't think we have it over here. Let's see. Is that the one? 0 0.02, 0.4, 0.0. Okay, we do the same thing. But no. That's weird. Maybe we wrote it different. Never mind, we keep it at 0. I think that's better. And if we merge them, let's see. We are on the inside, which is good. There's nothing pointing out what I can see. Maybe we need to take down the sweep a little bit. Take this down to 14, just to be safe. That's good. Yes. And it's safe all over the place. Good. So there we go. We then could convert these VDBs. Like I said, this is a lot easier. And convert it into a polygon. And we do attribute transfer because we want to keep the U and the class. Humps class and U. That's good. Then we want to group it. So we're going to do group. And we could probably just take the body, which we have here. We should one thing that's hit me. We should probably merge the body down here. So we have... No, that fucks things up, of course. Don't do that. We want the arms like this, I think. We should do a VDB combine instead. But anyway, we do like this. We take bring it down here. We do a VDB from polygons. And we do VDB merge, VDB combine. We combine these two. We bring this down to 0.1. And we do an SDF union. SDF union. And we have this. Okay, they're a bit... Yeah, because then we smooth it. Okay, we have to do it after the smooth, apparently. So we do that, and then we do that. Okay, my mouse gets fucked up. I don't know why. What's going on? I'm gonna see if my sun is on my AnyDesk thing. No, it's not. I don't have any. Okay, strange things. It felt like the mouse was moving. This guy's here. What's going on? What's that? Convert VDB, VDB combine, VDB smooth. Sorry, that's going wrong way. So we have that, which is good, and then we have to convert VDB. And we still lose a little bit of things here, which is strange. I don't know what's going on here, because... Okay, maybe we smoothed it too much. Maybe we need a little bit higher resolution, actually. It's gonna do 0.7. And now when we combine them, that looks good. Cool. Yes. And now we can convert them. And those arms are really small, but that's fine. So let's group it. And so we have this. Just gonna get it down to something manageable. Do like that. And we could just peek it a little bit. Oh, I hate when I do that. Peek. And points. And bounding regions. Bounding object. Okay. Doesn't want to plug in there. Let me see here. I think it's good. I'm just gonna pick it tiny bit. Okay. Let's see how that looks. Yeah, that's fine. Good. So this group is called body, muscle body. Body. And then we do a new group. And here we could just use, we have the VDB smooth here, and we can just, this is a bit chaotic, but if we just reshape VDB, reshape, and we dilate it 1, I think that should be enough. And run to points, bounding, volume. That's good, and we call it muscle arms. And good. Then we can do the same operations we did last time. Just put on a wrangle. And we say if group muscle body is equal to 1, f at muscle body is equal to 1. Forgot the at. And we do the same thing with the arms. There we go. Give group attrib. And then we do our attribute blur. And we're just gonna say muscle arms and muscle body. And we're gonna give it 300 iterations. And then we're also gonna do a group for the whole thing, which is called muscle. And that should be our primitives. And then we can do a null here. Let's call it out static muscle, because we don't want them static in the end. And what we could do is we could just, we have down here we have our, oh, that has to cook a little bit, sorry. I thought I saved this though. I guess there was some, I was gonna see here, didn't I save up here? Okay, so it has to cook those things, yeah, okay, that's why. I should probably do another file cache here called, because this will take a little while. Good, we have our thing here. We can do a file cache here as well. Grouped final poly. I'm just gonna do operator string, no frame number, save current frame, save to disk. And we can load from that. So that's good. And what we can do now is we can just start a little new. We have our muscle here. Do like this. Muscle, I wrote there. I'm gonna do a null here as well. Gonna keep it inside that. Out grouped final polys. And what we can do now is we can start down here, do an object merge. You could of course also do subnetworks if you rather want that. So out grouped final polys and also out static muscle. Yes, so sorry back. I just realized before we move forward that the arms are too small. It will be a problem. We can keep them small in the end maybe, but I think I have to lower the scale again back to where we were. Just to get this setup to work. And because the fact is that I try this right now with the smaller arms, and the problem was that it didn't hold up, the skin was loosened from it, which is a problem. So if we do like this, it might be better. I think this is better. I think this can handle the arms better. So we're gonna go back to that, and I'm just gonna recache my that's fine. I just need to recache the final polys grouped, because here we have them merged with the, or do we merge muscles? No, we bring it out there. Good. So I don't have to do anything with that. I just have the muscles there. That's good. So now we're gonna look at okay, so we're back and are going for the simulation, pretty much, or setup for a simulation. So we have both our object that is pretty high res at the moment, and oh, of course I haven't cached this before, which is the bit. But we will move away from this high res land very soon and be within something that's a lot more manageable. So just bear with me for like a little while, and we'll get down to when we have our TETs, and those will be a lot fewer. So we start here. The thing is, to be sure that we have no problems, we're gonna do one thing. We're gonna do connectivity here again, and we're just gonna measure the, it doesn't matter if it's area or it's, oh, we should do primitives maybe. Let's call it piece. I like to call it piece. And then we're just gonna measure here, because I think the measure has that by default. No? If we just say per piece, and then okay, it's a class. Sorry, should have kept it with class. Doesn't matter. It's not important. Just gonna say copy piece here. Go down here, and this will take forever. As you can see, it takes forever. If your computer can handle this, otherwise you just go down in resolution, because I think I went overkill here. Here you can see it's already bugging out. Yes, piece. Let's measure the area. But we're and then we just blast off. What you could do before all this is actually doing a poly reduce, because we won't use this high. We could actually do it up here just to save, just to be like a little bit more. Or we can do it. We can measure. No, we can do it here. I think it's fine. Or should we? Let's do it here. Do a poly reduce, because I mean we won't. I mean even if we go high res, I don't think we use more than 50% of the polys, and I think we can safely do a poly reduce and without any problems. So yeah, sorry. Before this, we're gonna do blast, and we're just gonna say if area. Do you spell it like that? I'm so bad at spelling. Sorry. Yeah, you do. It's less than 2. I think would be enough. That's only taking away. That won't take away any of our important stuff. Just takes, if there are small islands that, I mean, that could happen with the SDF. So if there are small islands, they will get blasted off. I don't know if there were, but it's just a precautionary thing to do, so that we don't end up with something that's off. So we're gonna do a poly reduce. We're gonna keep it down to 50%. I think that's more reasonable, and I think you can do that without losing any detail pretty much, because it's like there's been no optimization whatsoever about on the geo. So I think that's fine. This will cook for a little while, of course, and we'll wait. I might grab some coffee while we wait, and I'll get right back to you. So I'm back with my coffee, and we have a poly reduced thing which is down to 4 million polygons. That's safe. You can of course keep it at what level you want, and you could, I mean, eventually we will do the pointer form to get it back to this, because now we're gonna do it to tets and stuff. So yeah. Anyway, I was told that this thing, when it's animated, look like 2 octopuses having sex, and that's, yeah, just be aware of that is what you will produce in the end. Both my wife and some dude on Facebook said exactly the same thing. So yeah, well, enough about that. We are gonna do a remesh, and what we're gonna do is we're gonna put down 2 remeshes. Sorry, because we're gonna have a low poly and a high poly mode. I think it's a good idea to have. Or semi-low poly. The thing is that you need to have it at least a little bit high res in order to see what's going on. So we're gonna do target size 0.35 for the low res and 0.12 for the high res, I think. I'm not sure about that, might be off, but yeah. So then we're gonna do a switch. The reason I'm not plugging this in is because it's easier to, I mean, we don't have to. So let's say this is low, yes, and this is high. So the thing is, when we iterate over it, we're just gonna use the low res, and then we switch to high res when we do the sim, I think. So I guess that's easy, and we're gonna do a file cache here. I'm just gonna call this. I'm just gonna delete that. I'm just gonna delete the frame. I'm just gonna call this low res, and then I'm gonna do a copy that's called high res. So it's high res 1 because we already have one, and then we do a switch again, and we take these out, and we have just gonna see here we have the low res as input 1. So this is kind of other way around. Fuck it, it's fine. We're just gonna copy this parameter and paste it over here as well, so we don't accidentally save the wrong thing. So we're just gonna use 0 here, and if we go here, we could then plug these in, and it will take a little while. But we are computing the low res now, which is good. The reason I have file cache here as well is because this remeshing takes some time, so it's nice to be able to just load and save. Yeah. So I don't know what to say here. I probably should fast forward this, but I might not. Who knows? Maybe we can just have a quiet little chat. Oh, it's so fast. We didn't have to fast forward. So that's good. Then we can just cache this if we want to, so we don't have to worry about it at the moment. Then we're gonna do a solid conform. You could of course do like fancy stuff with, yeah. You could do a null where you switch around, or you could do, yeah, I don't see any reason to do PDG for this, but yeah, you could do those kind of things if you want to. So what this solid conform does, it should also add a surface triangles, is that it, of course, as you might know, makes this into a nice tetrahedral surface. And here's the thing as well, we have, you see those on the inside are lower res and those on the outside are higher res. And with FEM this, I think, causes problems a lot more than it does with Vellum. I think it's quite okay with Vellum, although we could bring it down a little bit. I mean, this should also be like, depending on the resolution, of course. But I think those are a little bit too big. We might, maybe I went overboard with 0.2. I'm not sure. No, I think that's fine. We have something that's definitely workable. And as you can see, this is layered into 3 groups, or you might not see it, but what we have here is we have something called surface triangles, which is basically this. And if we clip this, you'll see this. It's a hollow surface. And those, yeah, those will have 2 constraints on them. They will have the bend constraint and they will have the stretch constraints, triangle stretch. There are some things off on this, which kind of annoys me, and I don't know what's going on there. It seems off. I don't know why. It's a bit strange actually. Let's look at this. Okay. So there's something off with remesh. I wonder why. Could probably fix this. I don't know if we have to on the low res thing, but it's definitely. Could do a fuse maybe. Let's see if that works. You have to go really high to snap it. Oh, I guess that would work. I guess we should have this on. I don't think this will be a problem with the high res, but I'm not if anyone know why that happened. I haven't had a problem before, so tell me please, cause I'm just gonna see so we didn't fuck up anything else. I think the other ones are fine. Yeah, I think the fuse didn't cause any problems, hopefully. Okay, so just gonna copy this. Okay, maybe we do like this. We do a null, sorry. Call it high-low. We make it red, and we also make it into a round thing. Hello, come on. Just gonna drop down an integer here. Let me call it high. The thing is low/high should probably be the thing, because we have low/high. Or we can just call it high res. That's good. And we have a do it as a. We should not do that. We should then do it as a something like a toggle. We do like that. Sorry. High res. So apply, accept. Then we copy this parameter. And we just paste it all over the place. So there we go. So now if we switch, we get high res. And we should just do like that then. Good, we can look at solid conform. Let's see if it works better. I'm kind of confused with the surface triangles because it has worked before, but when I did some tests for this, I had a similar problem, which kind of fucked up the simulation. Here we go. It's a bit off and it's not the same size, but that should not be a problem with the new Vellum, I think. I think they have a solution for that better. And that's working, I think. I think the resolution is a bit off and that's a little bit of a problem, but yeah. Or I don't know. I'm not sure. I'm just saying stuff that I don't really know anything about, I think, sometimes. And I guess we all do. And you shouldn't be too honest about it. We do a split here. And we put down muscle as the grouping we want to do. And that gives us that. And on the other hand, it gives us the surface triangles and the... yeah. So what we're going to do is we're just going to give this some values. Both for the muscle and for the other things. So we're going to start with the muscle, and I think this time we're actually just going to put down a point drop, but I think we might just run through the whole simulation with just the muscles to start off with, because I think that could be fun. And here we don't do that much difference. We're just going to bind in, and we're going to bind in muscle arms. And that gives us, I mean, pretty much a value for both the muscles and the body, because what's not muscles is body, so you see, it's very simple. So that's good, and we're just going to fit this. Since it's 0 for body and 1 for muscles, we can just fit it. And we want, the thing is we're going to do this as a multiplier for the tetrahedral stretch stiffness. So what we're going to do is we're going to say 10 times for the body and 15 times for the arms. We want the arms stiffer, or maybe we do 20 times. I don't know. I might go overboard here. I should never change stuff. I should just keep stuff as I had them before. And yeah, I will probably be sorry for changing stuff. But I already changed so much, so I don't know. I can't stick to one ID. We put down a bind export and we just call it stretch, I think. It's good. So there we go to stretch and we put down another, or we copy this bind export and we just call this damping. And damping will have a default value of 1, and then we just add in what damping we want on them. And the thing is, we want a little bit lower damping on these, because from what I understand, I'm not sure about this, and I might be wrong about this, but all my tests, so I'm quite sure about it, but it still feels like I don't have the sign. I don't understand why it is. But the thing is, if you go higher on the damping, it gets softer. The stiffness becomes lower. It doesn't, but it's, in my opinion, in my experience with my number of subset iterations, whatever. For some reason, when I add more damping, it becomes softer. I don't know if it's under-resolved or if it's because the energy loss makes the energy blur and makes that softer. I'm not sure, and I haven't really found any information on it. I mean, from what I understand, the damping is the energy loss, pretty much. But I guess that's also an energy blur somehow. Maybe someone that knows more about this, please explain to me and write in the comments or whatever, or email me. Whatever. I don't know. So that's why I have a lower damping on those. Let's go see if we name that damp. So that's pretty much it. Nothing fancy here. And then we could put down a merge here because we want to merge these. We should also be a little fancy here. Maybe we should do like the split in the middle, the silicon form in the middle, like this. Maybe, sorry, could just A this, but it's probably too long a stream. So we do like that, and then we do like that, and we call this muscle. We will, of course, also do fat skin. Again, but we start with the muscle. It will be faster, and it will be, yeah, I think it will tell us the base animation, so to speak. Okay, so the first we're going to do is we're going to put down a Vellum constraint, or the first constraint we're going to, I don't know. And we're going to do, sorry, group type, we want to do tetrahedral stretch. And we want to preserve volume. And the mass, we're going to calculate varying, and calculate varying for thickness. I'm just going to visualize thickness and see how it looks. So these are two new options in H18, and varying, if you take a uniform density, I think we can have density uniform actually. Yeah, so So uniform creates, look for one value over the connected geometry, and varying, try to computate it for each point. And I think this is good. I think this is a good thickness. Since we're having others, I don't know. That's way too much. I think it's 25. It's good. Or 3, maybe. It doesn't matter that much for the skin, or for the muscles. And since we're adding skin, I think might need 25. I don't know. So that's good. We then wanna do the stiffness, and this is way too high. So what we're gonna do, we're just gonna bring this down a lot. We're gonna have it quite soft, and we're gonna scale by attribute. The thing is, like, we add to this because we have a higher, don't have one here, we have like 20 and stuff, so it's not that low, but it's still very low. And then damping ratio, we're just gonna put it to 1 and then scale by attribute, and that way we get what we typed in instead. I don't know if you can do scale by value, scale by both. You can't really set the attribute. I guess you could just do stretch damping ratio and it sets to that. I don't know. This is what I do. Yeah, so that's it. The thing is, we're gonna have 2 more constraints, but those are for the surface triangles, and we don't have surface triangles right now. So I don't know, I put down .NET there, sorry. So we're just gonna plug this into .NET to start off. We're gonna plug in the constraints to the second one. And it seems too easy, right? And it is. We're gonna do more stuff, but yeah, we start with this. So we have the Vellum object, and we can plug it into Vellum solver, since we have the default is OP input 0 and 1, which you can see here is the constraints. Initial constraints, yeah, exactly. And then it's output 2, which is exactly what we want. Vellum solver into the output, and that should give us our Vellum object, as you can see. We're gonna add a gravity force, and to be a little bit precise, we're gonna add a merge, we're gonna add a ground plane, we're gonna put that further down, -2, we're gonna merge this in here, and we're gonna shift the order, yes, and I don't know if it's needed now, we're gonna bring up the substeps to 3 and constraint change to 150. Just so we have that, so we can have pretty much the same settings when we add more things and add high res, etc. It's probably not needed with 3 substeps at the moment. We could probably, I don't know, we'll see. So this gives us this. It's bouncy as fuck, and it's yeah, it's probably too soft, as you can see. But the thing is, like, when we add a fat, that will slow things down, and when we add things like that, that will slow things down as well. So I mean, these will be affected. These are Vellum objects as all, and they are not rigid. So, but yeah, let's try bring it up a little bit. Let's bring up to 100 and 200 instead. Just see how that looks. We could then change it around, but I think this is a good way. Now I'm also changing things from my original setup too much, so yeah, I don't know. This would probably just take forever to get something good since I'm doing so much. Yeah. The thing is, like, you see the body there gets a little bit too stiff. So yeah, the body, we don't want that stiff actually. We want the body to be able to shrink down more. But I guess that's quite good. I mean, these are some kind of muscle slash bones, so let's do 20 there instead, see what that gives us. And you see it's quite nice to iterate just with the muscles. It's a big ass muscle. I don't know if any squid has like a big heart muscle inside of it. Like I said, it's not realistic. It's just fun. So yeah, I'm more happy with this. The arms are a bit stiffer. Also gonna show you, I don't know if this, I'm just gonna do like this and bring up the damping to 15. I'm gonna see what that gives us. It will of course give us more fall off of the force, but in my experience it will also give us a softer look. Hard to tell right now actually. Definitely more fall off. It doesn't do that much softness. I think it might be like the last time when it was under resolved and it, I'm not sure actually, but this does not seem to affect the damping so much. I'm just gonna cache this and we're gonna look at the difference. So you can see what damping does. I mean, this is what damping should do, but in my experience it also have made it softer. So just gonna cache out the 35 first frames here, which will be done in no time. Good. And then we're just gonna see the difference when we bring out the damping down a lot. I do an extreme version here, and let's cache that and append it. Now it should of course not lose hardly any force, which is not what we want. So it should be more, yeah, you can see the bounciness there. It's like a bouncy ball, it doesn't lose anything. Which could be fun, but I don't think it's what we want. We want the energy loss to be quite a lot. And yeah, we can see the difference here. So this is a lot of damping. This is no damping at all. And as you can see, it looks okay. It's not more rigid, but it looks more rigid. Like the energy loss makes it look more bouncy bally and a lot more rigid, in my opinion. And I guess that's also what it is, because I mean, here you see the arms just fall down, and here it's like they tend to be more. Yeah. So yeah, we're gonna go with our medium option here. And I could also, like, to make this clear, I could also like show you, because I think it's good to look at this and try around things. I mean, we could also see what, like, if we bring that down to 0.2 and like 0.02, let's do something like this, just to show you what real softness would look like. Of course you understand it, but I mean, I mean, just to dial in the numbers, I think it's good to play around with these things. It will just basically just be flat, and I don't think it will be able to preserve the volume a little bit, but you see it's chaos. It's fun, but it's totally, utterly chaos. So that's not what we want either, of course. But it's fun, see how it's blowing. I love the tattoo stretch, they are a really cool constraint, and it works really well. So let's just go back to where we were. Just gonna control Z here to 20 and 200 and damping to 0.15. There we go. Good damping amount. But you can make the, I mean, you could also make the fat less damping, because that could be more flubbery. I don't know if you want that, but it's up to you guys. So I think we're happy with this. I don't know. I think we're gonna add the animation now before we add a fat. Or do we add a fat and then remove it? Okay, we add a fat and then remove it, and then we add animation. I think that's the good option, actually. Sorry. So what we're gonna do then is we're gonna dive into the fat skin stretch thing here. And what we want here is a little bit more complex, but it's still very simple. What I like to do, yeah, actually I'll watch this as well. What we like to bind out is the stretch, the damp, and one thing called bind export called suck. I want to convert the, it doesn't really matter because I'm just gonna bring in the sucker and call it suck. I don't know, it's just too long. I don't know, you really don't have to do this, because you could usually, I mean, the good thing would be to use just use the skin fat suckers, but I thought it was too long and annoying, so I just bind it to. Could have done this in Wrangle. I mean, it's very. This is like the worst workflow thing ever. Just disregard what I just did. So we just renaming that basically. We could rename the attribute. That we should do that. Sorry, we should rename the attribute. This is not okay. Gonna do attribute rename. Skin fat suckers. I mean, it is that, and we want that, but we're just gonna call it suck. I like to call it suck. We do that afterwards, so we don't have to care about that. So what we want to do now is we want to look at the stretch, which is an important attribute in most regards. And what we want to do there is we're going to bring in this. Are we actually going to bring in the skin fat suckers for that anyway? And we're also going to look at. The split is wrong. Sorry, that's why I don't see it. There we go. So I'm just going back and forth here. Sorry for that. So we're gonna bring those in, and what we want, you can see that if we look at this CD, we have it's very blurred out now because of reasons. So that you can see right now it's so low res, so it's just meshed out. But when we have a high res GO, it will work nicely, I think. So that's good. And that's that. The thing is, we want them a bit more solid. I don't know how much it matters. That's how I've done it before, so we're just gonna keep it like that. So yeah, so the skin fat suckers, we get that value from 0 to 1, of course, and we're gonna fit that range, and we're just gonna fit it to like 1, because we're gonna multiply all these things. We're gonna bring it up to 100, because like all values are extremes in some ways. We're gonna do the same thing with the arms. So the arms, you want a little bit more. Less stretchy, so we can bring it up to 15. And those two we're gonna multiply, and then we're gonna get the vector component of P or Py, and we're gonna fit that as well. And we're gonna fit that from -1.1 to -1.5, and we're gonna say 1 here. I'm gonna say like 50 there. Why do we say 50 there? Is that quite a lot? Well, yeah, okay. And yeah, that's why I had that. Okay, we're gonna start multiplying these. Let's multiply, so 1, 1, 1, and I think that the suckers will be very. Okay, fuck it. Sometimes I get confused my old setup, and I just, yeah. Seems very off. Well, okay, I will continue doing this and then look at it. So I also did this component fitted again, and between 0.3 and 0.9, and like 0.05. I just think this is okay. Fuck it. Let's see how this looks. Bring it into CD. Oh, wrong component here. Component 2. Okay, so that's for the bottom things. I don't care about that. Sorry, we're just gonna remove that. This is always the case when you have old setup. So this is what we will care about, and this is what gives us the top a lot cooler look. So we could ramp this because we want the fall off. The fall off right now is very strange because this is a multiplication, and the fact that it's 0.5 here, and then it's like in this very tiny area it's doubled, and it's doubled again and doubled again and doubled again. So because it goes up to 0.9, and that seems, you have to think about that this is a factor of 20. You have to multiply this 20 times to get to 1, but this is like 1.1, so in the time here it has like a lot of steps of doubling. So therefore, I hope I made that clear. So therefore we just can put in a ramp so we can have this thing a lot softer fall off, kind of. So we're just gonna do a spline ramp, and I'm just gonna add some values here. So what we want is it to be like super low, like 0, 0 there, and we can go B-spline and do B-spline, and like maybe, let me see, like 0, we can keep it at 0, 0, 5 maybe, and then we move forward like here, and there we can have something like maybe 0 0.1, and then here maybe 0 0.2, then here maybe 0 0.4, and then here maybe 1. So we have something like that, just to get us, I mean, that transition, it won't, I mean, you won't even see that much difference. You do, you see a lot more, but yeah. But then again, we don't want us in our arms, so we can do a mix here. We bring this into 1, and then we bring in a constant of 1 instead, and we can just mix this by our arms. Not that, but that. Sorry. We have to complement this. Or do we? What the fuck? Sorry. So mix, bias. This has a value of 1. And this clean fat arm should have a value of 1. Why doesn't this work? Okay, so there's something wrong here. Muscle arms. Sorry, that's the problem. Skin, fat, arms. There we go. Good. Good that we notice it now. And now if we look at it, the arms are still stiff. So that's what we want. So let's bring that into the multiplication as well. Good. And I think that's it. We can bind export this as stretch. And we can also take a look at the color here. And the upper arm seems very, very, very white. And I wonder why. The lower arm seems very, very black. So there's something off here. Yeah, this is off. There we go. So the arms are a lot stiffer. We can do fit range here just to look how it looks. So if we do like 50, sorry, 150, 100. So it's hard to tell here. What we would like to do is to visualize this. We should actually do like a ramp as well. We could do that. We can just do that just in order to see what's going on here. So if we do that, what is the maximum value? Is it like 50? That's max. Okay, the ramp kind of screws this up, of course, but let's say that's fine. So we do that, and then in this ramp here, we have to rename that ramp because we are 2 ramps here. Ramp 2. Who cares? Do it RGB color ramp, and what we should do here is like we can go from red at 0, and then we can go at like 0.1, and we can make that orange, and then like at 0.1 we can do something that's yellow, and then at maybe even earlier, maybe like 0.2 or 5. Then we add something at 0.1, just to see, because like the scale here is, there's probably some cool multiplication you can do about this. Some cool function that you can do that makes this automatic, kind of 25, and then we do like at here somewhere we do cyan, and then we do white. So you see that the suckers makes it a bit stiffer, so it's stiffer on the inside, and it's, yeah, this visualization is quite nice actually. It's kind of off, but yeah, we should probably fit this to 100. How high is the biggest one actually? Still, yeah, they like the suckers are super stiff. Might be too much actually. So I'm gonna bring this down. We're just gonna do a factor by 10 because the arms are still very, I think this is better. So this is a good visualization, and we're gonna bring this down to 100, and it's still white. Cool. So we can just skip these things, and we can just keep it as visualization. So that's good. We have the stretch, and we should have the damp, and we should have the suck. Suck we have. So we're gonna bring in damp. We're just gonna do a constant on that. And I think we're gonna... I'm not sure where we're gonna go. I wanna try something lower. I'm gonna see what did we have on the muscles. I don't know what... We have 0.15. Let's try going like 0.05 instead. Let's see what that gives us. But the thing is, yeah, maybe. I don't know, we might have to tweak other things. So that's good. We have the skin fat, and what we could do then is we can just plug it in here. And then we can look at a new sim. And hopefully this works. But what we're going to do before that is actually look at the bend and the set stretch. So we're going to bring in a vellum constraint, because now we want to constrain the surface as well, as you might remember. So let's do a bend constraint, and bend across triangles, and mass, calculate varying. We're going to do calculate varying for both. Gonna visualize thickness here. I think that's good. You see the other ones on the inside. I think that's all good. Yes, and here's a thing. You need to bring the stiffness down on this, because I think we have a little bit of... You could probably fix that, but right now on the low res, I think there are some intersections, and if the... yeah, it will probably break if you don't bring it down actually. So that's not very good. So good, we have the bend. And then we're going to do another vellum constraint. And that should be tetrahedral, triangle stretch, also for the surface. And this is a bit freer what you can do with, but overall we want this really stiff, because that's what we don't want the skin to bleed out, so to speak. And we're gonna do calculate. Can probably do varying here as well. I think that's good. And we're just gonna look at the thickness, and it's same thing as the other one, so really don't have to look at it, but we did anyway. So then we plug this in, and plug this in, and we're gonna go down here, and it's working. That's nice. And we're just gonna play this. And now it's a good idea with the sub-steps, I think. Of course, there are a lot of collisions down there. I mean, you could... The thing is, like the bottom thing, I think it can look quite funny if you play around with it. I did a lot of other animations, and I kind of liked how it looked one day, all the small things. Let's see here. This is quite nice. Maybe a bit too... I think it's nice. It's a bit bouncy, I guess, because of... maybe we need a little more damping on the... we need a more damping, I think. Because it's so bouncy at the moment. It's fun, but... it feels like it's not very... It's more like a rubber ball or something. This is crazy. It keeps all its energy pretty much. And it spreads. It's quite fun that it's like this, but yeah, I think we need to bring up the damping. We're gonna cache this and look at this. Oh fuck. Fuck it, we bring up the damping first. I think we went crazy here with the 005. It was way too little. one idea I had, but I think it's better to do it softer if we want to have it flubbering. So I'm gonna bring this up to like my previous value, and I think you will see a lot of, if we now just gonna cache 50 frames and get back to you. Yeah, so we're back, and here is the result. It looks kind of fun. It might be a little bit too stiff, but you really see the advantage of this workflow with you can keep a solid shape, but you still have like this bouncy thing here, which really feels like a softer part of the thing. To have it layered like this is quite nice in that way. So that's like the belly thing. But I think maybe we want to do it a little bit less. But one thing we could do as well is add velocity damping on the solver, which I think we should do, like 0.1 or something. I think that would also help us a little bit. But I'm also gonna bring the chat stretch. Maybe go in here and just I think the muscles were good, so we're just gonna, let's see. The thing is, like, the suckers also kind of, but we do like this. We put this down to 0.5, which gives us 0.5 on the body, kind of. So half that. And let's resim it with the changes. So I'm gonna do a new sim. Okay, so we're back, and here's the two sims. You see, here's the first one, and here's the second one. It loses energy a lot faster with the velocity damping. And I mean, maybe it went too much, but I still think maybe it's like a little bit too much loss. You can do what you want with this, but we're gonna add forces as well, so we want it to lose a little bit faster, so it's hard to evaluate at the moment. So good, I think we're happy with this at the moment. I think what we should do as well is look at this with a clip on it, just to give us an idea what's going on inside. And I think this is a good clipping point. There we go, we have one long arm. I want to see the long arms as well. So we can just sim this as well, a little bit. Just to see that everything works nicely. And what you can see here is, what actually helped this is the fact that the arm goes in this kind of shape. So this one will have a harder time slipping out. Because what happens otherwise is that the skin is not attached to the muscles here, as it is in a FEM solver, where you do the Vellum constraint merge thing. So it needs to be stuck physically. And what my experience, if the arm gets too thin or if it's too flat, it can slip out and move inside its body and play around. And the thing is, that's fine, but the arm loses a lot of its stiffness, and you can't really control it anymore with forces, since we add forces to the arms. You can see here this is working really nicely. The skin, like I said, it's not attached, so it's get a little flubbery. And yeah, the arm could almost escape, but it doesn't. It still holds it in. What you could do as well, you could do like things that punches out through the skin to make it hold, and would have a little bit problem trying to detangle that, but it would work still, and the surface triangles would hopefully hold up. So that's an option as well. But as you can see here now, this works as intended. And it's amazing how fast it actually solves this, considering that like all the objects inside and how dense it actually is. I mean, this is not dense compared to the high-res, but oh, sorry. Yeah, really loving this. Cool, so that works as intended, and we have what we want here. So now we're gonna look at the animation, and I mean, I just did something very basic, added some motions and stuff. So I mean, you're super free to do whatever you want here. But I'm just gonna do what I did last time pretty much, and hopefully that will, yeah, it's something at least. So what we want to do is we want to go back to up here with the split, and we want to bring a new, gonna do this to null, and here I'm gonna just gonna name this, make it a little bit nicer. The reason we have this suck attribute is we're gonna add like sucking from the arms to the floor, just because it's fun. And that could also be fun. You could throw this onto like a wall and let it slide down and climb down or whatever. I mean, there's so many options to do. I did a lot of tests, and in the end I just did this kind of basic thing because I thought that showed off the thing better. But like a sliding plane would be really, I think that would be fun. And we could do that as well. I don't know, maybe that's more fun. Just gonna call this setup vellum. Maybe we should include a split. Maybe we should include this silicon from as well. Maybe we should include all of this actually, because this is all for the setup. So let's do that. We have kind of, I'm just gonna move this up to the whole thing because it's kind of, it's all just the vellum setup. And this is just visualization, but let's keep all of this inside. Did it move inside? No, it didn't. Yeah, it did. Maybe it did. No, it didn't. Okay. Annoying. I'm just gonna control Z here. If you know a better way of doing this, easy, just adding everything to it, please let me know. Here we go. I'm gonna call it vellum setup. Gonna make it a nice color. I want to have this blue. Yeah, that's nice. We don't have any blue. So out here is animation. Animation, did I spell that correctly? Probably not. And let's see here, did we keep, yes, we have our U attribute. So just gonna start with looking on one thing. We wanna look at our U attribute just to see that it's working. It is, because that's important. And that's the nice thing, that you keep all the attributes. This is kind of off, of course, because it's so low res, but the idea will work. Great. Then we're gonna do a point wop. And the first thing we want to do is we're just gonna set up a little attributes here. Just gonna see that we're gonna bind in a class, and I hope that we still have that. Do we have a class here? No, we don't. That's annoying. Maybe I lost that because the class was up, arms class it's called, right? Do we have that? Arms class, sorry. I renamed it to be smart. No, what's it called? Wasn't arms underscore class? Arms underscore class. It's an integer. But it still's not working. Okay, somehow we lost it. That's annoying. Maybe, yeah, I think we maybe forgot to, yeah, we forgot to attribute transfer that, I think. Annoying. We have to go back and do that. Sorry. But it's a good lesson. So what we did up here was that we did connectivity, and here we created arms class, and we attribute transfer there. So down there we have arms class. But I think down there we still have arms class, yes. But the thing is, when we did, yes, that's good. I think when we bring it in here, and we do, gonna go down and look here, the arms class is 0, yes. So that's annoying. So I think when we did up here, we did a connectivity, and that did not screw it up. We still have arms class there, okay. So that's good. We still have arms class here, but down here we lost it. And I think that's because of the remesh somehow. So we're just gonna do an attribute transfer before we save it. We should probably do, we can just do after the switch. I'm gonna do it like that, both of them, and we're gonna transfer it from up here where we still have it. Could actually like transfer it up there. No, it's better to do it there because then we have 0 on the other ones. And we're gonna transfer arms class. We're gonna have a condition of, yeah, it doesn't matter condition because the other ones will be 0. So now we have 0 and we have the arms class. Good. Then we can resave this. And now when we go back here, step into this one. It has to conform it. Could put a save down after the solid conform as well, of course. So let's see. Here we have something. But if we do a random, okay, so it gave a value of so it seems like, I'm just gonna look what's going on here. So we have arms class 0 a lot. But what annoys me is that it seems like, okay, let's do like this. We're just gonna start by blasting off everything that's 0, just to see. Okay. Shouldn't do. What? Do you need to do like that? You don't need to do that like that for now. Okay. I don't get it why it doesn't delete those. That's really strange. Okay, never mind that. We edit that away. Okay, so I get nothing here. Good. Arms class. Is this because we have some kind of surface polygons? I'm gonna do a clip here to look what's going on. Okay, so they all have one. Is it a problem that we did this? No, we did a solid conform afterwards. They get 0. But they all have a value of... Okay, so it seems to be... Okay, but what annoys me is that the body gets something else. So this is... Okay. So just like, let's do like this then. Because here it will say that arms class is. So we're gonna do a wrangle here. Say at arms class equals to -1. So we have -1 for the body. If we go down here, we have to remesh, which is annoying, but yeah, just that. Okay, now we have that. It's just gonna see color here. Random attribute, arms class, random attribute, and then we're just gonna go inside and see. So we get the body to have that as well. That's fine. I don't really care about the body, but at least the arms have different. So that's good. And it should probably work with solid conform. And it should probably work here. If we look at that, we're gonna do color again. Random attribute. Yeah, that's fine. We have different patches, and of course this is a kind of strange, but we're just gonna apply this for arms, so it doesn't really matter. So we bring in the arms class. Sorry for all the confusion here. And what we want to do here is we don't want to fit this. We just want to remove that. We're going to remove that. And we're just going to remove this. We don't care about that. So the good thing with the arms class is that gives us we can get a random number because we have different for each one. And then we can do a fit range, and that range could be like 0.7 to 1, and that will be the speed of the arms, so they get different speeds. This animation thing is a bit over the top. Maybe I added a bit too much functions, but I thought it was fun, so you can do what you want. You can skip a bit of this and do whatever you want. I mean, it's super fine. Just gonna call it speed. Actually, we're gonna call it speed 2 because we're gonna do 2 speeds, and then we're just gonna. No, we're not gonna do 2 speeds. We're gonna do 1 speed. Sorry, that's just confusing. So then we do arms class, and we just add constant, whatever number here, and that gives us another. When we do random from this, it gives us another result, of course. As you can see, this was the result of the first, and this is the result of the other one. Sorry, we should actually look at this to see the difference. So it's different, which is the important thing here. And we're gonna do a we're gonna maybe just do a multiply constant on this actually. Constant, and we're gonna multiply that by 10. And then we're gonna do that as bind export that as an offset. So we have different speeds and with different offsets for each arm, which is good. And we're fine with this. So we can just call this point op setup speed and offset. Gonna remove that, and then we're actually gonna do an attribute blur on this, because it might be because it could be too harsh otherwise. So it will soften it up. And with a lot of, I think 500 is too much now for the low res, but yeah, it's fine later on. And then we're gonna do some up and down movement for the arms. And here's where we bring in the speed and offset. And this will be a little bit more complex, kind of annoying that I did it so harsh, but yeah. Drop down a point op and call this up down. So yeah, so we're gonna start off by binding in the U attribute, which is important. You can just look at that, and we see that we have this, which is good. This can be used for a lot of things. And then we'll do a lot of multiplications and just add up to the position. So we're gonna start off with where do we start this off? Yeah, we're gonna start off with bringing in the time, and we're gonna add to that, and we're gonna bind in our offset. I think that's what it's called, right? Offset. Just gonna see that it gives us values. Yes, it is. It's gonna add that to the time, which gives us different time sets for everyone. We're gonna bring this into multiplication. Multiply. And what we also want here is the speed. So we're gonna bind in the speed. We're gonna add that to the second input. It doesn't matter because it's a multiply. And then we're gonna have a third input, which is gonna be a parameter that we're gonna call speed multiplier, because this will just be a multiplier on the overall speed to control it easier. That's good. Then we're gonna add this, and we kind of bind in, or we could just do copies of it. We have the U here. Let's start by putting it here. Bind in the U, and in order to get up and down movement of this, we're gonna do a function, a cosine function, and that's good. Then we add that to another multiplication. There's a lot of multiplications here, and I could go through this, but I hope you have a basic understanding how these kind of things work. So this is not really about this. It's just more of a about the the simulation. So we take the U again, and we do a ramp parameter here, and this would be like apply ramp, where to apply this. So that should be spline ramp, and this is where on the U it will be applied, and that's why we multiply it in here. And we could also we bring in another one. So this will be a strict apply ramp for what we want. And let's then also, let me think here, maybe we bring in, do another one of these, and we call this shape, so we get a little bit more control. Shape ramp. Then we're gonna multiply that in as well, so we have two of these to control it a little bit more. We're then gonna do another, we could actually don't need to do another multiplication, we can just add another thing here, which could be a parameter, and this would be more of a amount. So let's add it in, and then we can, yeah, I think that's fine. Then we can do an add, or do we need to do an add? And what we're gonna do here is we're actually gonna, yeah, we're gonna do like this. We're gonna take the position here, bring in the position, gonna move this away like that. So we have the position, and then we add this, which will be off, of course. If we just plug it into position, it would be super strange, or nothing, because we have no ramps. But then we're gonna do vector, not add there. We're gonna do, what we're gonna do is, we're gonna do like a vector set component instead. This is the best way of doing it. So we set component 2 to this, and the other one we keep at 0, and then we do that, of course. Sorry. This is the problem. When you just look at your old setup and you try to follow it, rather than just doing what seems natural, you kind of make strange decisions. So we add that position, and then we go down, up, and here's the thing. Like, to apply ramp, we kind of want pretty straight, or maybe we want rather like this. Yeah, what we want to do is we're actually going to do it like this as well. Sorry. So after the cosine, gonna do a new multiplication, and we're gonna bring in. I think we could handle this with the u as well, but I'm gonna bring in muscle arms anyway, so we're just gonna multiply those again. So let's see if this works. We have a speed multiplier 1, amount 1, and there we go. It looks fucked up. 0.1, and there's something off here. And what is that? Okay, so I saw the problem. The thing was that I needed to blur lots more things. So I was spelling speed wrong, and I added muscle arms in U as well, because with this low res, I think we can remove it. With the high res, we will have to look at that, but with the low res thing, it was kind of a problem. So I took down the blurring activations to 100, and I added those. And what that gives us is something that works a lot better. But the problem now, I added a little bit. We can tweak the amounts here. I think the shape is quite nice. Maybe we should do like this and like this. And the apply, maybe we want to do like that, and maybe we actually want add a lot to the end here, give it 4. We're gonna add more. Yeah, the thing is now that you have a problem with the inner arms moving a bit too much. So we're gonna fix that as well. We're gonna add to a multiplication here. So what we could do is we could just bring in our position, and we can get vector to float, and we can take the x-axis, and we can do an absolute of that, and we can take the z-axis and an absolute of that, which gives us a value how far they are from the center pretty much. And we can just add these two. And then we can fit this range. And the fit range could be I don't know really, we have to try this, but let's start off with something 0.4, 1.6, maybe something like that. We're just gonna add it to the multiplication as well. Okay, so that didn't really work. Maybe it has to go 5. How far away is it? No, it's not 5. There, start seeing what's happening. Let's look at 3. Maybe source 0.5. No, let's do 0.8. So that's good. I think. Yeah. Let me go back here. And I think we could bring up the speed a lot. I think it's cool as, yeah, I think that's better. We're not doing real time now, but still I think that's better speed. And you see that I have random movements, which is fun. Could probably exaggerate this a little bit more, give it a little bit more motion. Double it, see what's happening. The thing is, you have to understand that this is a force. We will compare our rest place with this. So that's fun. The big ones are moving quite a lot. They will get a lot of force. I think this is fine. Cool. I kind of like this. Let's do it like this. We want them not just to move up and down. So we're just gonna copy this. Or maybe not. We're just gonna do something simple. Maybe copy this actually. We do that. And here what we're gonna do, we're gonna set vector component. Try to set vector component 1 instead. And we're just gonna bring it down a lot. So do that, and we set vector component 3. So that's crazy. As you can see, they move quite a lot to the sides as well. But only to one side. So if we just move that, we should see. I don't know this. Yeah, they're moving like to the sides, which is good. We could bring down the amount to like 0.2 maybe. We can do this, and we should of course then also wait. This is good. Speed and offset. Kind of boring that they are at the same place, at least the offset. So let's just bring in. How do we fix this in a smart way? We could probably. That's why we should do a speed value 2, actually. So, well, offset 2 at least. We do an offset 2 instead. Offset 2. Sorry, we can just do like this. And we just do another constant here, which just gives us another random value to use. And then we're gonna blur that as well. Set 2. So now we can use offset 2 instead, which gives us another random function. And they're moving a bit to the side, which is cool. Then we all. So cool. We have this thing. That's good, but we just want very fast jumps, because this is a 4, so you don't want to add it too many frames. You just want like a very snappy thing to it. And so what we can do, we have this 1 to 0 to 1. That's good. We can try to do something like fit range. We can have something like, or we can do a ramp here, so we still visualize it. We're gonna do spline ramp, and it still looks like this. And if we do like this, we say, so let's say that we have a value of 0.5 all the way, and let's keep it at 0.5. So now it's 0.5, and then it goes up, and we can tweak this to whatever we want. We want it up and down. And we're gonna move this a little bit so we don't do it exactly at the end, because we want to have a little. So what we want to do, I think, is to do something like before it starts. We're gonna have 0.5, and then this we're gonna do a little bit less. We have a little bit of contraction, and then we do our expansion, and then we go back to our regular state. So if we look at this, you will have, just to visualize it, you see it goes to like something a little bit darker, and then it's up. The thing is, now we have since we have a, we maybe should not use a cosine, because we get back and forth here, which is a problem. So it jumps twice. Might be cool, but it might also be a bit strange, because right now the cosine goes, since it goes way and back again. So let's use something other than a cosine. Let's instead use maybe if we use, just can divide it by a number. We see what number, maybe 10, and then we do a modulus by the same number. Or we do a modulus and then divide it, of course. Sorry. We do a modulus by 10, let's say, and then we divide it by 10. And what that gives us is this then. Let's see. It's a bit too slow. Yeah. We could fix that by doubling this. The good thing is now it goes down to 0 again, rather than the sine function that goes up to 0. I think this might be fun. Okay, so now we have a visual way of looking at this, and we have a value of 0.5 that is not anything, and then when it goes down, it just gets lower. So what we can do then is very easily just subtract a constant, of 0.5. Gives it black, and then it gets negative, which we can't see, but it goes down to negative. And that's off because it seems to not be landing at 0.5. Sorry, it's not. Sorry, my bad. Should go down to 0.5. So this gives us, of course, a value then, which is lower than 1 when we don't see it, and then goes up to 0.5 and go back again, which is good. So now this value could be, we could take the position and do an add, and we can take this and we can do a vector set component. We should probably move this whole thing, and we do that, and we set component 2, and we plug that in, and we add at the position. Remove this. So what we get now is this. It moves down a little and then up, and that's fine. We also want to do one more thing. We want to add to the X. So what we're going to do then is we're going to refit this. So we don't want it to move backwards, we just want it to jump up. And since we want it a little bit later, we can just do 0.1 to get to 0, and then we can do the same thing. Component, and we say that this is component 1 then, and we add that in as well. So what will happen now is this. And this is a force, as you understand. But what I think is that it might be, maybe the X should come a little bit later. Try 0.2, which also will make it a bit, so it gets up and then it gets forward force as well. And never mind that this animation looks like crap, that's not what's important here, it's a force that goes into it. Great. Maybe it's too continuous, I think. So what you could do, you could randomize this a little bit. You could do time, you can maybe do that into an, we could do time and we could just do a random from time, and then we could fit that. So we can just do like 0.8 point. No, we can't, because that will, I don't know if this would work. We can try this. We can just multiply this in as well. But the thing is, it might jump backwards, so we have to be very careful what we do here. It seems to be working. And now there you go. It goes a little backwards, which might be fine. It adds a little bit randomness to it, so it's not doing exactly the same thing. But yeah, sometimes it gets faster, sometimes it gets slower. I think it's fine. It just adds randomness to it. It's like I said, it's a force, so it doesn't really, the animation doesn't have to look clean at all. It can look like crap, which it does. So I think that's fine. Hopefully that will be enough. Yeah, so we're happy with that. And then we're gonna do a little bit, we're gonna do one more thing. We're gonna do a transform here. And we're just gonna add a little bit of rotation to it. Yeah, that's better. But we can't really do a random thing, so we're just gonna do 0.5 here. Just try to move in different directions a little bit. So I have a little bit of movement there, and a little bit of movement there. Yeah, I think that's fine. So never mind the random stuff there. It was just a bad idea, I think. Just, we don't want to add too much noise because it will get noisy anyway. So that's good. And what we want to do now is that we want to bring back in the other geo, which might sound counterintuitive, but that's what we want to do. So we bring this in, and this order here is important. You have to bring this in first and that one in second. That gives us the same point numbers. If you look here, 39, 713. sorry, not at the split, at the merge here. You see we have the same point numbers. And that's important, because when we look at the muscle, we want the same point numbers. And we can see that we have 3 to 7, 3 to 4 to 7. Yeah, we have the same number of points also, which is good. Then we're going to put down a normal here. We're going to move this down as well, I think, to make it clearer. We can do it over here maybe. And we're going to do a normal. And because we need a normal, and I think we need it on points. And then we're going to do a null. I'm going to call this out animated muscle. You can see here the muscle goes way outside the thing, which is good, which is what we want. And then we want to do the same thing. I want to copy this merge. Sorry. Copy this merge. Remove that input. And instead take this input and change them around. Let me see. Gonna look at the point numbers here just to be sure. Don't want to see too many points. Do like this. And we have that there. And we have, no, that's wrong done. Yeah, now it's correct. That's good. And then we're gonna give this normals as well, and point level. And we're gonna call this, copy this, and call it out static muscle. And that's good. We have these. And what we can do now is go into our .NET and add these functions. So what we're going to do now is we're going to remove the skin again. We're just going to dive into .NET. That makes it faster and a little bit simpler, and we get more instant feedback on what we're doing. So diving back into the .NET, we will drop down a subsolver. And this is kind of standard. I've done this a couple of times now, so yeah, you might know what we're gonna do. So we're just gonna plug it in the particle forces, and we're gonna dive in. So this is quite simple. We have a dot geometry, and we're gonna bring that then into a point triangle. No point wheeled, sorry, point triangle. Why can't I get a... There we go, point triangle. And then we're gonna do to object merge. And what we want is to bring in our animated muscle. And our static muscles. Oh, we have two static muscles. That's kind of annoying. I know that's the one, but I'm gonna call this rest muscle instead, because we have it. I know we have it up there, so we're gonna call it rest muscle 1. Don't know why the one. Yeah, I know where the one came from, but yeah, who cares? So out rest muscle. Good. And you have normals, which is good. So we have a point triangle. We're gonna call this compute force, and we're gonna plug our rest into first input, or input 1, our second input, and the other one to input 2, our third input, just to be confusing. So we're gonna do something simple. We're gonna create a vector which we call target, and we're gonna say equals to point, and we're gonna say input 1. And we're going to look at position P, attribute P, and we're going to do that at point number. This is why it's important to have the same point number, because we can just use the same point numbers to calculate stuff, which is really handy. And we're going to do vector source deformed, which is our deformed geo. And we're going to do point 2, Gonna look at P there as well, and we're gonna look at point number. And this way we get two vectors saying how the rest looks and how the animated geo looks. And then we're gonna do v at rest normal, not capital rest. We want capital N because normal always has that in Houdini. So let's do that. And we're gonna say point 1, and we're gonna look at the normal, and we're gonna look at the point number. And this, the reason for this is that we need a rest normal to compute how it has moved compared to its rest state. And I'm gonna visualize this, but at first I'm gonna add this, and we're gonna look at that thing. So we're gonna see temp velocity equals to source deformed minus target multiplied by a scale, which we can call amount of scale. And then we're gonna actually look at, we might want more on muscle arms, so I'm gonna add that option to add more for the muscle arms. And we're gonna do like 1 and 115 to start with. It's not that big difference, but I'm gonna do it anyway. So like that, I think is fine. And fit muscle arms, comma, 0 to 1, 1 to 1.15. Sorry. And we're also gonna add actually another fit, and we're gonna fit time. So we might not want it when it falls down as much. I don't know. So we're gonna do like 0.7 to 2 and 1 to 0. Just be able to control when it starts. But just be annoying, I'm gonna do like this for now. Because when we iterate, it will be good to see it. So what we can do now is we're just gonna point on a point up, and we're gonna copy the temp v to the velocity, which is gonna save first. I'm bad at saving. I guess we all are, but I don't know. So we're gonna bind in the temp v. I think I call it temp v like that, right? Just gonna double check that. Yes, I did. And we're just gonna say that that's 3 vectors. I'm gonna take the velocity. I'm gonna add to that. There we go. I'm gonna bind it as velocity. Could as well do this, just add it to the force. It doesn't really matter. I like to do it like this. So that's good. So that's the basic setup. This, however, will get problematic, and I'm gonna show you why. But first, let's look at this. Oh, we forgot the scale though. So let's bring in a scale of, I don't know, 34. I don't know. That's actually just a guess, because I don't know stuff right now. So let's reset simulation. Here we go. And see if it's working. Not sure if it is though. It doesn't seem to be working. So let's dive in and see what's wrong. Just gonna add a marker for temp v. Okay, let's see here. temp V. We don't have it. That's just strange. I guess it's something to do with... Okay, just look here. Bring that in, that works, that works, that works. Good. So here we do that, and we get the value called temp V. But, okay, I see the problem here. We do temp V, but we do it like that. There we go. Now we have a temp V, and we go down here, this will probably work, sorry. Underscores or no underscores, always what confuses me. You see, we have a lot of force there. Way too much probably. So let's look at it. Okay, it's swinging all over the place. 34 was definitely way too much. Okay, so it goes crazy, which it should not, of course. So let's take this down a few notches. Let's bring it down to 3 instead, and look what we gets us. Gonna reset the simulation. The thing is, we have to also think about the fact that this thing will not be as it is. The thing is, we have the same density on this and the skin, so when this has to drag the skin along with it, it will lose like 90% of its energy. So who knows? We see that it's working now, so that's good. One thing with the problem here is that you don't want... I'm gonna show you, I'm gonna visualize this now. We're just gonna look how it looks with the skin on, just to see that it's quite a lot of difference. So let's look at this. And we take longer to solve, of course. And the problem here is that the force, when the arms are moving straight up, the force still keeps pointing upwards, which is not what we want. We want the forces to be bent with the shape, so to speak. So we want it, now it's jumping. That seems to be doing that quite okay. It seems to be jumping quite a lot. We'll see how that plays out. One other thing we're gonna do as well is we're gonna add a little bit of counter force where we... Okay, I think it's a bit too loose because it stretches out so much, which is fun, but yeah, quite off. So it's jumping in the X direction, which is what we wanted. It's quite fun. It's quite fun to have it so jumpy. Let me play blast this before we lose simulation here. I'm gonna change direction so is somewhere around here maybe. So we get the jump towards us, which is fun. So I'm just gonna play blast to 50 frames and you can see what it looks like. Yeah, it's quite fun. Maybe we keep it like this. I mean, there's no reason to do exactly the same thing as last time. So I think this is... I'm just gonna do 171 if we skip that first annoying frame. I think that looks cool, funny, just jumps forward. And it's very playful with its arms, crazy stuff. So that's cool. Let's do it like that. Great. So we're happy with that thing. Now we have a problem which is not clearly visible here, but what's happening is that the force is not really caring about where the arms are. So it just pulls down. You can see it here that the arms just get pulled down. It doesn't really follow the flow of the arms. And I'm gonna visualize this to show you. We're doing a force, so we're just gonna do a grid here to show you this. It could be 10 by 10, that's fine. Just gonna do a soft transform here to get a little bit random stuff. And what we're gonna do is gonna say 40 to 59. I'm just gonna move this up a little bit. Just gonna do give it a little bit of soft radius. Not that much maybe. So we do like that, which is good. I could give this a normal on the points. There we see that. And I'm gonna do a transform here. I'm gonna move this up a little bit more. Like this. That's good. I'm gonna transform, we're just gonna rotate it. So I'm gonna say $F -1 because we want to start at 0. So we have that. And it rotates. And I'm gonna give this normals as well after the transform. So what we have here are these. And now I'm just gonna take this thing here because I want to. Our thing is rotating, and what it has is a force. So we can do like this. We can put that on a angle. And we're gonna say V at force equals to 0, 1, 0. We say we have a basic upwards movement. We're just gonna visualize this. Okay, we have temp v, so we say temp v instead, because that's the same attribute we have. V. Like that, we see that. And the problem is, this is not very good. We don't want it to push that way when we're there. We want it to follow the flow of the geometry. It depends a lot what we're doing. I think right now we're not a problem, but if the squid were to be upside down or oriented completely other way, it would definitely screw things up completely. So yeah, this is a problem and it can be fixed. So what we're going to do is we're going to plug in this one here, and what we want to do is we want to say we want to create a rest normal, and that's equal to 0.1 normal and add pt now because we have the same amount of points, which is essentially what we did in our solver as well. Then you can do this in Vex or with a VOP. I do it with a VOP because I'm lazy and stupid, so I can't handle it in Vex. I can maybe, but who cares? Yeah, it's quite simple. You could do this in Vex, but who cares? So the idea here is to calculate the angle and how much it has rotated. And both things is quite easily done with the cross product and the dot product. So we bind in and quickly dot and cross product. I can show you if you don't know what it is. You kind of should know it. I mean, you shouldn't know it by heart, but there's a good reason to know it because it's very, very useful. We're gonna plug it into normal just to look at it. We're gonna remove the force just to see that it works. It doesn't work. Ah, sorry. Classic. Free floats. Okay. Why the fuck doesn't it wanna bind export to normal? It's really annoying. This is confusing. We have rest normal and we plug it into normal, but nothing happens. Just kills it out. Maybe we have to just re-put it. Yeah, now it works. Good. As intended. So, let's go back to this. So what we're gonna do is very simple. We're gonna plug this out and we're gonna take the normal, we're gonna take the rest normal and the normal, and we're gonna do dot product. So what's the dot product? The dot product is basically the angle between the angle between two how big the difference between the angles are. So we do it like CD. You can see here they're at the same place. They are rotated a lot away, and if we're to do this, I'm gonna speed up the rotation here a little bit. To left -1 multiplied by, oh, we do that first, multiply by 2 -1 -2 then, I guess. So we go here, and if we look at this, we go to that, and there we go back again. So it gives us a value saying how far the angles are between the normal and the rest normal, which is good. Then we're going to do another thing. We're going to take the normal, and we're going to, just to be super safe, we're going to normalize it. It should not have to be normalized. And we're going to take the rest normal, and we're going to normalize it. It should not, they are normalized already, but still. And then we're going to take the cross product of these two. And what that gives us is the perpendicular angle of the normal and the rest normal, which is nothing here. But as you can see here, and just a little disclaimer here, this function and this way of doing it is not perfect. We will have a problem when we cross the 180 degree. Down here will be a problem. As you can see, it shrinks down. Although we normalize it, it will still be a little bit of a problem. So yeah, you see it switches sides here, which is what it happens. You could compute this every frame as well, but it's not needed for this. We just want something approximation. So what we do then, when we have these two, is that we do a quaternion. And the quaternion is just want our angle from the cross dot product. No, it doesn't, because we forgot something. The thing what we need as well is we want an arc cosine function for this. So we're going to go to trigonometry, and we're going to do arc cosine function of this. It gives us a value that looks like this. It's hard to tell here, but it's a trigonometric function. And I don't really remember this, but I think like arc cosine is like the inverse thing of a cosine in some way, right? I'm not sure. I shouldn't say things that I have no idea, and I'm not sure if we need to normalize that. I don't think so. I just see the difference. And we take the quaternion and we convert it into a matrix. Matrix 3, which is a rotation matrix. And then we can just take our temp V, which I think was called temp underscore. No, not big V, right? Because we don't use big V. No, exactly. And this is of course free floats, and we can plug it into the normal to look at it. It looks like that right now, but with a little bit of magic and multiplication with the matrix. Gonna move this. Hopefully it looks okay. It does. It rotates along until we get down here and it fucks up, but fine. We don't care about that. It's like that would be like 2 points, and it doesn't matter at the moment. Like I said, you could computate this for each step instead, so you compare it with the previous frame, and that would clear out that problem. But it's not at all needed. It's definitely not now. Maybe sometimes it could be good, but yeah. Let's gonna see what happens if we normalize this. It might fix a little frames that are problematic otherwise. It does. It fixes most of the frames. It still get chaotic there, but since it's normalized, it fixes those where it gets very, very small. So that's good. So this is, we're super happy with this. And now you say, why don't you just use the normal? Well, the fact is that in the end, our force will not look like this. Our force will rather look like a X noise at P, maybe we can just do. So our force rather looks like this or something. Maybe we higher the frequency. Yeah. And the thing is that Okay, so now we get a rest noise each frame, so okay, that's the problem. So we just, okay, we do like this, sorry, just to show you. We had a rest position here, and we do X noise over the rest instead. It's gonna time shift here. So let's do it like this, 1, and then we do that. And now, here we go, it shouldn't be. Yeah, so fuck it. Sorry. There we go. As you can see, it works with this as well. I just plug it into normal. But we have problems when we get to that angle, but yeah, we're fine with that. So I don't know if we need to visualize this thing. We just remove the rest, and we're just gonna do X noise. Remove the X noise and just set it to 1 0 1 0, and hopefully just edit this out, this whole thing. Yeah, so that works. Good. So let's go back and implement this on our solver. So we can just copy this whole thing, pretty much. Don't need a normal thing, so we can just copy this. And then we jump into our squid. And we don't want to simulate a couple of million frames. And we jump into the .NET, and we jump into the subsolver, and we jump into this point pop, because this is where we want to convert that thing. So we have rest normals. This is getting plugged into P, which is completely wrong. And this also goes into P, which is completely wrong. We should get our normal and our normal there. Good. And then we have a temp V, which is what we want there. And can move those. We have the temp V here, and we multiply it. Yes, that's gonna confuse there. We calculate temp V every time. That's why we use temp V. So we can just add that to the velocity. And if we were to keep the attribute, I mean, that's why we don't use the velocity straight away. So now we add a temp V there. We rotate it around the rest normal. Just gonna check here. So we have rest normals, right? We have rest normals. Good. Good. And it's all good. And since we only check the PT num, we don't get any effect on the skin. So let's look at this then. Let's just preview a few frames again and see what's happening. Gonna close down as well. So much stuff here. So I'm gonna preview 50 frames for you guys. Oh, a bit too far away. Just gonna crop this. Okay, so here's the first. Oh, it's chaotic, but yeah, still a bit too much force probably. Should probably take that down. Maybe the upwards thing is a bit too much. Although I like it, I think like this stretching thing here is quite cool. That you really see that the skin is pulling up afterwards. Get this kind of nice thing. But I think I'm gonna take it down a little bit, and then we're gonna go back. Sorry, it's a bit chaotic. So basically we can just, I think maybe we can just take down the whole thing a notch. So we can take down scale to 2. And one last playthrough before we look at the arms thingy. So I'm gonna flip book one more and get back to you. So we have a new sim here, And I don't know if it's a little bit too weak now actually. I think the front movement is too weak at least. I think we should add more to that. But let's first add a little bit stickiness to the suckers, which I think will be a cool thing to kind of counterplay the other force. So let's do that. I'm just gonna, sorry, 1 second. It's always a bit of a hassle here. So yeah, just gonna dive into our .NET and what we want to do here is bring in a Vellum constraint because we want this to be created inside the dops. And we want on the post solve. Oh yeah, I don't think it really matters, but what we're going to do is we want to create each frame. And we want to, what we want, I just realized maybe we should do a basic box first to do this with, because we need to attach it to something. We could of course attach it to the ground plane, but I think we'll start off with what we could do in order to just visualize it, put down a grid on the same place. So our ground plane is at -1.5, I think. Yes, it is. This grid is big enough. Yes, it is. So let's do that. We just say out grid. And this will just be a temporary thing. Since we are gonna do a real collision object later on. Not that advanced, but yeah. So what we want is to each frame and want to attach to geometry. And we want the group types to be on points. And we want to have skin fat suckers. And we're gonna go calculate uniform, I think is fine here. What's your thickness and, oh sorry, not density. And calculate uniform. And we want target troop crest to be primitives, and we want it to be grid out grid. And what we want to do is we want to do a max distance that is like very low, 0.1 maybe. I want it to be able to slide a little bit, like 0.1. And the stretch stiffness has to be a lot lower, so we're going to take it down to 0.1. Bring it up to 5. And then we're going to scale by suck attribute. And that's basically just it. Resting scale we're going to keep at 1. And we're going to have braking, very low threshold. Like 0. I don't know. Something like that, maybe. No, that's too much. I'm gonna do -4, -5. And we're gonna stretch that, and I think that's it. Okay, so stupid mistake here. The grid is on object level. So stupid. So just gonna go in here and move it down inside instead, because that will work. So it attached to this, which was kind of off. It worked, but it attached wrongly. So now we're gonna go back. We don't have to see the grid, we can see this grid. We're just gonna look what's going on here. So let's play this. So we're back, and this is how it looks. It's a bit jittery, so I'm gonna check what's going on here. It seems a little bit off. So I'm gonna drop down a Vellum IO here. And that makes it easy to just look at the constraints. So I'm gonna do a null here. And here we have the constraints. Right? No, can't we do that? No, we're sorry, we have to do like this. Sorry, we can't just plug it into Vellum IO. We have to drop import. Drop IO. and we're gonna take that top network, and we're gonna take the top node geometry. Does that give us that? Yes, good. There we got everything, and we just want the vel star. We get that, and then we do the same thing with collision geometry. It's not called like that. What's it called? Just gonna see here. Constraint geometries. What the fuck? Sorry. Why would it be collision? It's constraint we want. Constraint geometry. There we go. Here we have the constraints. And if we look at this, we can see what type it is. And we're gonna do like that, and we're gonna see, I think it's called type right. Type, there we go. And if we check the type, we should have, we could sort by this. And we should have attach, there we have the attach. So we can blast off everything that's not attached. Just to look at those. At type equals to attach. Delete non-selected. There we go. And if we then highlight this, we can see that they are attaching way off. And that's what's wrong. And why is that? It seems we're just gonna highlight the grid as well. There's the out grid, and they're not even close to that, so there's something wrong here. And I'm not sure why that is. Okay, so I'm kind of confused on the ground plane is -2. Oh, I make idiotic mistakes. Sorry for that. So we changed that -2. Now things should be correct. Sorry for hustling. So always nice to be able to do some debugging. So let's say that that was the reason here. So let's try this again. Gonna do a new and play. Okay, so we're back here. We can just go back and see this one. We start at 54, so let's do that. And it's working. You see that they kind of stick on the ground, which is fun. We could do it more and see how that plays out. I mean, right now it's just testing things out and resimming, and yeah, like I said, it takes some time with that little bit high res, but I think we're getting there quite close now, so I think it's fine. Just gonna try adding a little bit of harder to break them and see what that gives us. So we're gonna go in here and we're gonna max this. I think works, but we're gonna try adding stiffness by a factor of 10, because usually it's no point in adding less than that. Because I like the thing, I like the fact that it gives a little bit more to it, and we're gonna bring the threshold up a little then, so it's harder to break them. And we're gonna sim this. And it takes some time here, I know. It's not that much to do. We can go a little bit closer maybe, so we see a little bit more detail. And I'm gonna recache. Okay, so we have a new sim. We can look at the two after each other, so we see the difference. So here's the previous one, and here's the new one. You see, it gets more attached with arms. It has to struggle a little bit, and you see that the bottom part of the body actually holds up a little bit if you compare to this. You could probably do it more, but I mean, I'm happy with this. It's a subtle effect, and it adds a little bit to the complexity of it. So I'm quite happy with this. I think we're pretty much done with this. We should of course then switch to high res and sim it. And let's take things forward and doing that. We could, before we do that, we could maybe set up. Maybe we should move forward with the real collision object first.